Hey guys, I want to do a quick review here for quiz tomorrow. I want to go through basically one question of each type that will be on the quiz. So, first section will be on the quiz. This 2.5. These are the ones where we added them together. Remember, use multiple colors. Colors really do help keep things organized. So, first thing I would do with these again is try to find the periods. You got to find the periods of both of them individually. This part here, well, the b values 2 would have a period of 2 pi over 2 or 1 pi. The second one, this one, would have a period of 2 pi over 4 or pi over 2. So remember, this one's going to count every pi, 1 pi, 2 pi, 3 pi. This is going to count every half pi, 1 pi, 1.5 pi, and so on. So the period of the whole thing is going to be kind of the first time they overlap. So the period's going to be 1 pi. Okay, remember it's kind of like a greatest common or least common multiple kind of thing, common denominator type of thing. So first thing I would do is when you find the overlap one, I like to do the bigger one first. Okay, so I would put my axis in. Okay, I'm going to go out to pi. Midpoint of that would be pi over 2. Midpoint of that would be pi over 4. And then this would be 3 pi over 4, right? This one has an amplitude of 2. 1, 2. Okay, and then I'm going to draw that sine curve. So midline, peak, midline, peak, midline. Okay? Draw that curve as best we can. Okay? And now we got to draw the other one. Well, the other one has a period of pi over 2, so we're going to be done by the time we get here, which means we need some more points in here. So midpoint here is going to be pi over 8. Then we can pretty much just count by 8s. 1, 8, 2, 8. This would be 3/8. We are going to end up needing these as well. 4, 8, 5, 8. 6, 8. This would be 7/8. Okay? And then we can draw that other curve. Now this one has an amplitude of 4, and it's a cosine curve. So we got to go up to 4, 3, 4, 3, 4. Okay, and then we can draw that curve. So we got to start at our peak, and then we go midline, bottom peak, midline, top peak. Right? And then we're going to have to keep on going because we got to get them to match. So we're peak, midline, bottom peak, midline, top peak. Now remember, doing this, all we're doing here is this is the equivalent of us just plotting a ton of points. This is not our actual graph. We're just using this to plot a ton of points. What we now have to do is we have to use this to draw our real graph. Okay? Now, our real graph here, I'm going to try to line these up as best I can. And keeping our spacing as accurate as you can really does help. If you have bad spacing here on your x-axis, it's going to make your graph look a little bit weird, and it'll be really difficult to get your graph to look like the calculator. Notice, I haven't touched my calculator yet. Yes, in the end, we're going to end up using our calculator to do the majority of the work, but I'm not going to touch that just yet. Now, notice I'm going all the way up here to 6, okay? And the reason I'm going up and down to 6 is if you look at your 1, 2, 3, 4, 5, 6. If you look at your two amplitudes here, this one has an amplitude of 2, this one has an amplitude of 4. If they do happen to peak at the same time, we have that potential of getting to 6. All right, so now remember, we're going to use this to start plotting some real points down here. We need a few points that we can connect the dots with. So we're 0 here, we're 4 here. You add those together, we're at 4. This one we'd have to estimate. This one we're at 2. This one looks like we're, between 1 and 2. So if you add those together, we're going to be probably between 1 and 2, somewhere in here. Now, this one's at 2. This one's at -4. So we add those together. I know I'm going to be at -2. Okay. This point's at 0. This one is between 1 and 2. So we're probably going to be between 1 and 2 again. Probably about the same height we were there. Here we're at 0. Here we're at 4. So down here we'll be at 4. And then 5 pi, we're 8. We're at 0. And then we're at about -1. Probably should be a little bit lower. So, but we're probably going to be right in here somewhere. Now here we're at -2. Here we're at -4. We add those together, we're going to be way down here at -6. So there's going to be a dip down there. And then 7 pi over 8, we're at 0. We're at, maybe a little bit less than -1. So again, probably about the same height we were there. And then 0 and 4. We add those together as 4. And that's important to make sure. Remember, we have to start and end at the same spot. That way we know we have a full cycle. I'm not just going to connect the dots yet. Now is the time I'm going to grab this graphing calculator. Okay? This is what we're actually trying to draw. But this is getting us some good points. But we really need this graphing calculator to do the majority of the work for us. Sorry, my daughter's on a Zoom meeting, if you can hear that. So, sine of 2x plus 4 cosine of 4x. Okay? Let's type that in just like it is in the example. Now, before you press graph, you got to make sure 2 things. 1, we have to be in radian mode, because that's what we're graphing in. We got to fix our window. Remember, x min, that's our, left boundary. So we're starting at 0. Our x max is our right boundary. Well, we're going all the way out to 2 pi. The x scale is what are you counting by? Oops, I didn't press the 2. 2 pi. Okay. Our scale is what are we counting by? Well, we want dashes every pi over 8 to help us find those points. And then our x min or y min, y max, I'd probably go to 7 just to give us that little bit of a boundary. I know we're not going to get to 7, but that gives us that little cushion there. All right, now we're going to use this to connect the dots. Okay, we know we're at 4. And find these points, especially like we think there's a dip right here at pi over 4. Is that dip really at pi over 4? Yeah, it looks like it really is. So it looks like we can just kind of connect the dots there from the first one to the second one. Okay, I don't know why I grabbed my black pen. Okay, and then find this next point. Well, this next point, it looks like it's there. This peak right here looks like it's right at pi over 2. So this does look like it actually is a real peak. Okay, so it looks like we're peaking when we get to there. Okay, now looking like we're going down here to -6. Okay, now if anybody notices a problem, what mistake did I make here? My mistake is I'm actually only going to pi, right? Notice this looks like I graphed 2 cycles. So really what I probably should do is fix that. My x max really should have only been pi, right? Now press graph. Now it should look more like what we're doing. Okay? Again, bottom peak, we're going up, top peak, coming down, bottom peak down there, and then it looks like we're just going to connect the dots there. Now again, some of these graphs do look really, really funky. If the only thing you do is use the calculator and you don't do this plotting of points, I can tell you your graphs are not going to be that accurate. It's really difficult to use a calculator on a funky looking graph like these and draw an accurate picture. When you plot these points, when you draw this curve, I'm going to be pretty picky on what your graph looks like. If this point's up here at 6, or this peak goes up to 6 and this one only goes to -4, you're going to get points taken off. Okay, so make sure you're drawing this graph to plot the points. That way you have real data points that you're just kind of connecting the dots. Okay, but don't just do that to connect the dots, because really, in all reality, we're not plotting enough points. If we wanted to plot points and just do that to connect the dots, we really should plot a lot more than what we just did. But we're kind of doing a combination of both. We're going to plot some points to get a decent number of points. Then we're going to grab the calculator to connect the dots. Okay, and that's a good way of getting an accurate graph. All right, so that's section 5. We are going to have one or two of those. Don't worry, I'm not going to put a ton of those on a test or a quiz because I know they're time consuming. All right, then we have our tangent graphs. Remember, the big difference between sine, cosine, tangent, or sine, all our different graphs is the period. The period for tangent and cotangent is 1 pi divided by the b, not the 2 pi. These are the only two that are different. Okay, so in this case, my period is pi over 4. Okay, I'd have a phase shift of left pi over 2. I got to go down 2. Remember, this is more of a stretch. It's not really an amplitude here. So first thing I would do, I'm going to go left to pi over 2. Now remember, this graph here, this is the only one. The tangent graph is the only one that's different. Okay, this graph is the only one that we're going to start in the middle. Our middle is right here, down 2. We know we're going to go through that point. We got to work out from the middle here. Okay, we know our period is pi over 4, right? So that means I'm going to have to go half of that distance in both directions. So I'm going to have to go pi over 8 in both directions. So this is like 4/8, -4/8. So if I add an 1/8, I'd be over here at -3/8. If I add or subtract, I'd be at -5/8. Make sure you're labeling these at 2 asymptotes. Okay? So remember, tangent is the only one that's different, that you start in the middle and work your way out. You're going to go half of your period in both directions. Okay? And then you can draw your curve. This is a tangent curve. It's a little straighter than normal. It would look like that. Okay? So again, how I'm going to grade them, I'm looking for just a couple things. You only have to have 3 points. You got to have your midpoint and your 2 asymptotes. Is your curve going the right direction? And is it, I don't draw all your tangent and cotangent curves the same way. At least have a high, medium, low kind of thing. As far as straight, kind of a normal curve, S curve, and then a small one. This next one would have a small or a sharp curve, because this 1/4 would mean, I like to think of it as the road. You'd have to drive slowly through that curve. Okay. Again, my period would be 1 pi over 2 now. I'm moving right 3 pi over 4 and up 3. So I would go right to 3 pi over 4. Now, remember, cotangent is more like The other graphs where I'm starting at the beginning. Cotangent, it's not a midpoint, that's your first asymptote. And then I always want you to go to the right from there. So my period is a half. If I add 3/4 plus 1/2, well, that's the same as 2/4. So 3/4 plus 2/4 would be 5/4. And that's where my other asymptote is. Okay? Remember, with both graphs, the gap from one asymptote to the other asymptote has to equal your period. That's true in both the tangent and the cotangent graphs. Okay? That gap. The cotangent, your phase shift is an asymptote. The tangent, your phase shift is the midpoint. Okay? That's the big difference. We still have to find our midpoint here. Just add those together and divide by 2. 3/4, 5/4 would be 8/4. Half of 8/4 is 4/4, or 1 pi. I'd have to go up 3, and that's where my center point would be. Remember, the other difference between tangent and cotangent goes down, and this is going to go down, it's going to be sharp. So I come down, go almost straight across, and then I go down there, okay? So that's how I'm going to do the tangent and the cotangent graphs, okay? Remember, tangent, your phase shift is your midpoint, you work out from there, half of your period in both directions, okay? And feel free just to grab your calculator. You know, this one was, come on, turn on. I'm at negative, this one I was at what, -1/2? So you can just type in -1/2. I'm going to add 1/8. Math, enter. So -3/8. And then I'm going to basically do the same thing, but I'm going to minus 1/8. Okay? And that's an easy way to get that. Okay? So don't be afraid to use your calculator to get your fractions if you're having trouble with that. Okay? This one down here, phase shift is your asymptote. You add your full period to get to your other asymptote, midpoint it back to the other one. So this one's more like your sine and cosine graphs, where you start at the phase shift, add your period, work back to the middle. Okay? 2 more graphs. So let's go through the cosecant graph. Okay? Remember, first thing I would do is basically graph the reciprocal version, the sine version. Okay? Everything else is the same. So amplitude would be 4. Period again, 2 pi again over the b. Phase shift would be left 3 pi over 4. Vertical shift down 1. So I'm going to graph the sine version. Okay. So I got to go left. So again, it wouldn't be a bad idea. Don't be in a hurry to put your y-axis in all the time. Just go left 3 pi over 4. Add your period. Okay, period would be 1, -3/4 plus 1 would be +1/4. Midpoint that. Okay, notice I haven't put my y-axis in there. You don't have to. Okay, -3/4 plus 1/4 would be -2/4. Half of -2/4 would be -1/4. Now it's really easy to find where that y-axis is. That's the midpoint over here. Midpoint over here would be -1/2. All right, got to go down 1. Draw that midline. Make sure you guys are drawing that midline in there. Okay. My amplitude is 4, so I'm going to go up and down 4, 2, 3, 4, up here to 3, 1, 2, 3, 4, down here to -5. Okay. And then I got to draw my sine curve. My sine curve would be midline, peak, midline, peak. midline. Now again, remember, you can draw the sine curve here if you want to. You don't have to draw this part, okay? That's not actually part of our curve. I just like to draw it in there, okay? But that also tells us where our asymptotes are. Our asymptotes would be anywhere it hits the midline. So I have an asymptote over here at 3 pi over 4. I have an asymptote at pi over 4. And then I have another asymptote at positive pi over 4. And now I can draw my curve. The tops of the sine curve, that's going to be the bottom of the U shape going up. The bottom of the sine curve, that's going to be the top. Okay? So that's what I'd be looking for. Again, you don't have to have the sine curve drawn, but you do have to have the asymptotes. And I'm going to be looking to make sure that this peak goes up to -5, this peak or this trough comes down to +3. Okay? One more. I'll let you guys go. Secant graph. Okay? Remember, I would draw the cosine version. So amplitude is 2. Period again, 2 pi over 4. So that'd be pi over 2. Phase shift, right pi over 2. Vertical shift, up 2. Okay? So put your x-axis in. I'm going to go right pi over 2. So in this case, I can put my y-axis in. I'm going to go right to pi over 2. Okay? Add my period. So pi over 2 plus pi over 2, that would just be 1 pi. Didn't do a great job of spacing that, but that's okay. Midpoint that would be 3 pi over 4. Midpoint here, so let's see, that's 2/4. 2/4 plus 3/4 is 5/4. Half of that would be 5/8. So midpoint this, 3/4, that's 4/4. So 7/4. Half of 7/4 would be 7/8. Okay. I'm going to go up 2. Draw that midline in there. That really will help keep things nice and neat. I got to go up and down 2 from there. So up to 4, down to 0. Now this is a cosine curve. So I'm going to start at a peak here. So that's at 4. And then I'd be midline. Bottom peak would be down to 0. Top peak up to 4 here. So again, now we have asymptotes anywhere it hits the midline. So I'd have one at 5 pi over 4. And I'd have one at 5 pi over 8 and 7 pi over 8. Again, you don't have to draw in the cosine curve if you don't want to. Remember, all our secant graphs, our up U is kind of split. That's just kind of how we're drawing it's because of how we draw our cosine curve. And then down from that bottom peak, oops, I went over my asymptote, that's all right. Okay, and then if you want to put your little eyeballs and smiley face in there, you can too. All right, I can't look at this and not see a little guy. So, all right, but quiz tomorrow, it'll be those types of graphs. Probably, kind of expect one of each kind of thing on the quiz. That'll be that. All right, I will talk to you guys later. Have a great afternoon.